video, that is physicists from different countries and their contribution. Okay, this one content will be discussed in complete video lesson number 2. Let us start the discussion. Here I have actually kept a physicist name, then followed by the country of their origin, that means to which country the physicist belong, and his or her contribution. Okay, in this manner I have actually kept the table. First is physicist name, second is country of origin, then their contribution. First physicist is Archimedes. Archimedes belongs to Greece and he has given 2 contributions towards physics. The first contribution is principle of buoyancy. Just 1 minute here. And the second contribution is principle of lever. 2 contributions he has given. Let us actually explain one by one. First, let us take a principle of buoyancy. I'll write here. Principle of buoyancy. See, when it comes to principle of buoyancy, to explain this concept, we will take one vessel like this. One vessel we will take, and let us actually fill the vessel with water. Okay, we have filled the vessel with water, and what we will do is, here one opening we will keep. Okay, one opening. Let us assume that the tray is up to this height, and here immediately after the surface of water, one tap like structure is there. Okay, opening. Okay, let us actually imagine this as one tap, and we will keep one vessel here, small vessel. Okay, any container. Okay, we will keep one container here. What we will do is, we will take one object we will take. Okay, hanging object. Let us actually hang this object and let us actually hold here. We will be holding here, and this is the object. This object, what we will do is, we will actually immerse this object into the water. What will happen? Let us actually immerse half of the object. Okay, after immersing half of the object, what will happen generally means, the water level rises, no? Okay, the water level rises. Whenever we immerse, some level of water will rise, and that water, extra water which will rise, will be collected in this tray. That is common sense, no? Whenever some object is immersed into the liquid level rises, and the extra amount of liquid what it rises, it will be collected in the tray. Okay, common sense. And according to the principle of buoyancy, here whenever we immerse the object into the liquid, upward force from the liquid will act on the object, it seems. That force is called as buoyant force. Okay, and the principle of buoyancy tells that this buoyant force will be equal to the weight of the water which is collected in this tray. This is one case. Okay, the buoyant force which will be acting upward towards the object will be equal to the water which is flown from this tap into this tray. This weight of water in this tray will be equal to the buoyant force. Case number 1. Let us let us take second case. See, in the first case we actually immersed half of the object. Now in second case, what we will do is completely we will immerse. Okay, this object, let us actually immerse completely into this fluid. See, when we immerse completely, what will happen? Definitely extra some other amount, that means extra amount, still some amount of water will come into this tray, because completely we have submerged. Initially what we did, only half we submerged, but in second case completely we submerge. So some other extra amount of water will be collected in this tray, because water level rises, no? Okay, and this is case 2, completely submerged. And in this case, what they tell is, the volume of water what it is collected here, no, the volume of water, that will be equal to the volume of the body. That means this body, the volume of body. Okay, this is case number 2. The volume of water what it is collected in tray will be equal to the volume of body submerged. This is case number 2. These 2 cases will explain the principle of buoyancy. Okay, very much clear. This is the buoyant force, upward force acting on the object. Okay, that's it guys. This is principle of buoyancy. Now let us actually go to the second principle. Just 1 minute. here. Second principle, principle of lever. Let us explain this one. Okay, I will just put one arrow mark here so that one line I will keep, because there should not be any confusion. Okay, principle of lever, here we will explain. Just 1 minute. Okay, principle of lever. So lever means this is one structure of lever. Okay, one complete one big scale we will take. Let us imagine this is a one big scale, and this scale now we will actually fix this scale on one stand. Let us actually imagine this is one stand, and scale is actually fixed on that stand. And let us actually consider this as some 5 meters. Okay, in 5-meter distance we will keep one object. Okay, this is object number 1, and in another 5-meter distance, 5-meter distance, this side we will keep object number 2. Okay, let us imagine that this object number 1 is some 10 kg. 10 kg will be the weight of the object number 1, and the object number 2 is also 10 kg. So in this state, the complete lever will be in equilibrium. It will be actually balanced. Okay, because it will be in equilibrium. But what happens means, if we actually move this 10 kg of object 1 towards the midpoint, not completely midpoint but towards midpoint. Let us say we actually move this object number 1 towards midpoint, around, so let us actually move 2 meters from this distance. I will write the diagram here like this. 2 meter means I'll actually, so let us imagine this one. Initially it was 5 meter, but now we actually moved 2 meter. So the distance of object from the midpoint will be 3 meter, because 2 meter we moved now. So object will be here. Initially it was here, but now it is here, object number 1. But object number 2 will be 5 meters distance only from midpoint. So what will happen in this case? Definitely this will tilt. No, actually this will tilt. Actually in this direction it will tilt, because here 5 meters away the object is. Okay, see, the point to be kept is we are not varying the mass. Mass is same, 10 kg 10 kg, mass is same. The only thing what we have changed is we have moved object number 1 near midpoint, so that what will happen, it will tilt because of the distance. Okay, difference in the distance will be there, so it will tilt towards greatest distance. In this manner it will tilt the lever. Okay, this is what is known as the principle of lever. Very easy and simple concept. Now let us actually move on to third one. Just 1 minute, guys. Here, third one or what? Second scientist, third principle. Okay, scientist. Who is the scientist? Second, Galileo Galilei, very famous now. Galileo Galilei. He belongs to Italy, and he has given law of inertia, the concept of law of inertia. So law of inertia, to explain law of inertia, I will explain here law of inertia. See, according to law of inertia, if no net force is acting on a state of, if no net force is acting on an object which is in a state of motion, if no net force is acting on an object, this is object, let us actually name it as OB. OB is an object, no net force is acting, and the object is already in some state of motion, so it will continue in the state of motion. That's it. Okay, that is law of inertia. That means if no force is acting, net force is acting, the object, if it is in the state of motion, it will actually continue in that state of motion. Okay, and what happens if some force is applied to this object? The state of motion changes. Okay, until we do not apply any net force, the state of motion of object do not change. That is what is known as law of inertia. Okay, now another one example I will take to explain this law of inertia. Let us take one ball. Okay, some ball, cricket ball we will take. You people will play cricket now. Okay, one cricket ball we will take, and this ball will be actually moving on this floor. Okay, with some state of motion it will be moving, some state of motion it will be moving, and if somebody comes and actually stop this ball, okay, some force is applied, the state of motion changes. Okay, anyway, if the state of, if somebody comes and actually applies the force in this direction or in this direction, the state of motion changes. If they apply force in this direction, the ball will actually move very slowly. If they apply in this direction, the ball will actually move fast. Whatever may be the case, whether it is moving slow, whether it is moving fast, but the state of motion changes. Okay, if nobody comes and apply the force on this ball, the ball continues to move, no? Okay, in the same state of motion as initially, in the same state of motion it will be moving. Okay, because no net force is acting. Only when net force will act, the ball will change the state of motion. That is very simple definition or example of law of inertia. Okay, Galileo Galilei. Now let us actually move on to the third scientist. The third scientist is Christian Huygens. He belongs to the country Holland, and he has given wave theory of light. The contribution out to physics what he has given is, here I will write, okay, design okay, wave theory of light. Let us actually explain this wave theory of light. See, a simple explanation of this wave theory of light is, let us actually imagine that here one mirror is there. Okay, we will actually, okay, keep one mirror here, and what we will do is one image source. Okay, one image source, rays from image source will actually point towards this mirror. What will happen? Definitely the ray will get reflected. Now because it is mirror, that is the reason the ray will get reflected in this direction. Opposite direction it will go now. If you actually pass the ray like this, it will go like this. And when second ray will come, it will go in this direction. And it will not go here, it will go here. Okay. And when the third ray comes, okay, like this, it will actually go in completely reversed fashion. Okay, so according to this law, the destination image what we will get, it will be a reversed image of source image. Whatever the image it was in the source, the image will be reversed when we get in destination. That is what is known as the wave theory of light. In wave theory of light, they say this principle. Okay, image source is there. When it reflects from mirror, the image what we get in the destination will be reversed image. The image will be reversed. Very simple definition or example. So that completes the third scientist contribution. Now let us actually move to fourth scientist, Isaac Newton. He belongs to UK, and he has given three principles. Okay, major principles he has given. The first is universal law of gravitation, laws of motion second, the third is reflecting telescope. Okay, see, you may ask us, sir, what is this universal law of gravitation? See, it is very famous. No, we already know universal law of gravitation. Okay, I will write here upwards. Universal law of gravitation is given by this formula: F is equal to the gravitational constant and the product of masses and the radius, square of radius. Okay, this is what is the formula, famous formula, which explains universal law of gravitation given by Newton. Very famous law. Second is laws of motion. See, laws of motion will actually tells us the relation between motion and force acting on the particle. Okay, the relationship between force and motion is given by laws of motion. Okay, and the third one, reflecting telescope. What is this reflecting telescope? See, reflecting telescopes are nothing but they are used in many applications. For example, they are used to observe or examine. They are used to examine visible region. Okay, in electromagnetic spectrum. See, in electromagnetic spectrum, a visible region will be there. To examine that visible region, this reflecting telescope will be used, and this is the contribution given by Newton. Okay, so now let us actually take up fifth scientist. Okay, the name of fifth scientist is Michael Faraday. Faraday belongs to UK, and he has given law of electromagnetic induction concept. Okay, see, law of electromagnetic induction is used in application like induction motors. In induction motors, this principle is used, and also in induction cooking, this principle is used, and also in electric generators. In electric generators also this principle is used. Okay, some of the applications these are. Okay, and to tell what is there in law of electromagnetic induction, it is like predicting how magnetic field interacts with electric circuit to produce electromotive force. That is what is there in electromagnetic induction concept. Okay, I'll actually repeat it again. To predict how magnetic field interacts with electric circuit to produce electromotive force is there in laws of electromagnetic induction. Now let us actually move on to the sixth scientist, James Clerk Maxwell, and he belongs to UK. He has given electromagnetic theory, and also he says that light is nothing but it is an electromagnetic wave. According to Maxwell, light is an electromagnetic wave. Okay, according to electromagnetic theory of Maxwell, he says that light is nothing but it is a propagating wave of electric and magnetic field. Light is nothing but it is a propagating wave of light is nothing but it is a propagating wave of electric and magnetic field. That is what is there in electromagnetic theory of Maxwell. Okay, very simple sentences. Okay, next, uh, Rudolf Hertz. Okay, Heinrich Rudolf Hertz. He belongs to Germany country, and he has given the concept of generation of electromagnetic wave. Okay, see, according to Hertz, the electromagnetic radiations, I'll write here. According to him, the electromagnetic radiations are produced whenever charged particles such as electron changes its velocity. I'll repeat it again. Electromagnetic radiations are produced whenever charged particles like electron changes their velocity. That is given by the Hertz in his theory. Okay. Next one, J.C. Bose. Okay, from India, no, we should be very famous. I'm sorry, we should be very proud. Very famous person, J.C. Bose, Jagadish Chandra Bose. His name is from India, and he has given the concept of ultra short radio waves. See, ultra short radio waves are nothing but it is radio transmission using short wave radio frequencies. Okay, the next one, what is this? Roentgen, his name is, and he is from Germany. Okay, and he has given the concept of X-ray. See, we know no X-ray. Everybody know X-ray these days. What is X-ray? Whenever something happens to our body, we will go to what? Where we will go? We will go to clinics or the hospitals. We will go. In that hospital, they will actually examine, and if some fracture has happened, they will actually send us to X-ray. Okay, X-ray we will take now in hospitals. Best example, best application of X-ray. Okay, to examine bones and joints in hospitals, they will actually see. Okay, for fractures, if something has happened to bone, joints. Okay, to examine body parts, mainly bones and joints, X-rays are used. Application I have told. Okay, but what are X-rays? X-rays are nothing but they are penetrating form of high energy electromagnetic radiation. They are penetrating form of high energy electromagnetic radiations. That they are called as X-rays. Very much clear. Now let's actually move on to the 10th scientist. The name of the 10th scientist is J.J. Thomson. He belongs to the country UK. Just 1 minute, guys. Okay, he belongs to the country UK, and he has actually contributed towards electron, giving the concept of electron. What are electrons? Electrons are nothing but they are negatively charged subatomic particles. Okay, the electron can be bound to atom or may not be bound to atom. Okay, you may ask, sir, only electrons are subatomic particles? No, we also have neutrons, we also have protons. Electrons, neutrons and protons are subatomic particles. And the concept of electron was given by J.J. Thomson. See, you people have to memorize the scientist name, country of origin, and what contribution they have given. You have to memorize it. Okay, once you understood the concept, you have to memorize again and again so that it will actually retain in memory. So, memorization you have to do. The next one, 11th one, Marie Curie. Very famous now, from Poland. She is from Poland, and she has contributed towards the discovery of radium and polonium. Radium, what is the symbol of radium? Ra. Polonium, Po. And what is the atomic number of radium? It is 88. What is the atomic number of polonium? It is 84. 4 less, you just remember like this, 4 less. Okay, and she has also given studies on natural radioactivity. These are the contributions of Marie Curie. Now let us actually move on to Albert Einstein, very famous, no, from Germany. He has given two very bombard concepts. One is photoelectric effect and second is theory of relativity. Okay, see, when it comes to photoelectric effect, it is nothing but whenever whenever some light is falled, some radiations or light, let us actually keep an example. Whenever light is actually falls on the metal plate, electrically charged particles are emitted out of this metal plate. Okay, that is simple explanation of photoelectric effect. Okay, formally speaking, we can tell like this: the photoelectric effect is phenomena where electrically charged particle, the photoelectric effect is the phenomena where electrically charged particles are released from or within material when it absorbs electromagnetic radiation. That is the formal explanation of photoelectric effect. But simple explanation here: whenever light falls on metal plate, the electrically charged particles are released from the metal plate. That is the very simple explanation of photoelectric effect given by Einstein. Okay, this is the first one. The second one, what he says is theory of relativity. See, very famous, no, theory of relativity. See, within theory of relativity we have general theory of relativity and special theory of relativity. Two things are there. In theory of relativity, they speak about time and space. They mainly speak about time and space in theory of relativity. Okay, the next one, the next contribution is from Hess, Victor Francis Hess, HESS. He is from Austria. Okay, not Australia, you have to remember, it is Austria. He is from Austria and he has given the concept of cosmic radiations. Sir, what are cosmic radiations? See, cosmic radiations are high energy protons and atomic nuclei. They are high energy protons and atomic nuclei that move through space comparable to the speed of light. They are called as cosmic radiations. Okay, that's it, guys. Now let's move on to the next scientist, 14th one. Next scientist name is Millikan and he belongs to USA and he has given the concept of measurement of electronic charge. Okay, and 15th scientist, Ernest Rutherford, very famous now, from New Zealand. He has given nuclear model of atom. Very famous nuclear model of atom. We know, no? See, in nucleus there will be protons and neutrons. Okay, we will actually imagine this as one nucleus. So one nucleus is there. So we will actually shade these objects. We will consider this as protons. Okay, we will shade like this, randomly we will shade. Okay, something like this will shade. Okay, see, the complete this one is, let us actually consider this as nucleus we will consider, and we will consider this as some neutron we will actually consider, and we will consider this shade and the particles as protons. Okay, this is nucleus, it has neutrons and protons, and this electrons, no, they will be actually revolving in electron orbit around nucleus like this, electron orbit. Okay, here electron will be there, these are electron, okay, electron, and these are electron orbit, this one is electron orbit. Okay, so this is the nuclear model of atom given by Rutherford. That's it, guys. Now let's move on to the 16th one, Niels Bohr. Okay, Niels Bohr, no, he belongs to Denmark country and he has given the concept of quantum model of hydrogen atom. Quantum model of hydrogen atom given by Niels Bohr, very famous. The next, C.V. Raman from our country. Okay, C.V. Raman actually tells about inelastic scattering of light by molecules. Inelastic scattering of light by molecules is given by C.V. Raman from our country, India. The next, Louis Victor de Broglie. Louis Victor de Broglie belongs to France country and he has given the wave nature of matter. The contribution of de Broglie is wave nature of what? Matter. That's it. Now let's move on to the 19th scientist, M.N. Saha from our country, India. M.N. Saha has given the contribution of thermal ionization. The contribution of thermal ionization given by M.N. Saha. The next, S.N. Bose from India, given the contribution of quantum statistics. The next, Pauli, okay, Wolfgang Pauli, the complete name is from Austria, not Australia, it is Austria, and he has given the concept of exclusion principle. Okay, the next scientist is Enrico Fermi from country Italy, and he has given the concept of controlled nuclear fission. Okay, here I want to tell the difference between fission and fusion. What is fission? What is fusion? Okay, fission is nothing but splitting of atoms into two or more small atoms. Splitting of atoms into two or more small atoms, whereas fusion is completely opposite of fission. It is actually fusing. Fusing of smaller atoms into bigger atoms is called as fusion. Splitting of atom into smaller atoms is called as fission. Fission means splitting, fusion means fusing. Okay, very much clear. The next one, Heisenberg. Okay, Werner Heisenberg belongs to Germany country, and he has given the concept of quantum mechanics and uncertainty principle. Okay, see, you may ask, sir, what is this uncertainty principle? See, uncertainty principle says that just 1 minute, we cannot know both position and speed of a particle such as photon and electron with perfect accuracy. That is what is told. With perfect accuracy, we cannot know position as well as speed of particles such as electron or photon. Electron or photon, we cannot actually predict exactly the position and space. That is what is there in uncertainty principle. Very simple. Okay. Now let's actually move on to the next one. The next one is 20. Just 1 minute, guys. 24th here. 24th scientist is Paul Dirac. Paul Dirac belongs to UK country, and he has given relativistic theory of electron concept as well as quantum statistics concept. Okay. The next is Edwin Hubble. Edwin Hubble, very famous, no? Expanding universe, the concept of expanding universe given by him, and he belongs to USA. The next one, Ernest Orlando Lawrence. Ernest Orlando Lawrence, and he has given the concept of cyclotron, and he belongs to USA. We know no cyclotron, they are nothing but particle accelerator. I will write here. They are nothing but particle accelerator. Okay, I'll explain the concept. One ion, consider this as ion source. Okay, consider this as ion source. One ion will be there, and this particle accelerator, what they will do, no, they will actually move this ion in circular fashion. Okay, in this spiral fashion they will move, and that ion will be actually here. This beam, no, this ion which is actually circulating, it will be actually directed towards target, and this will be in this direction. This ion which is circulating now in spiral fashion, it will be in this direction, and one chamber will be there. This closed chamber will be there. I will write this diagram like this: closed chamber, and here one hole will be there. Okay, this ion will come and hit the target here. This is target. This is target. This ion will come and hit the target here. Okay, this is what is cyclotron. Cyclotron will look like this. Okay, just keep in mind that they are particle accelerators. Okay, only this one you keep in mind, cyclotrons. Okay, no need to actually go and scratch your head of this diagram and all. Okay, don't worry about this diagram and all. You just know like cyclotrons are nothing but particle accelerator. Okay, you know this much. Next one, James Chadwick. James Chadwick belongs to UK country, and he has given the concept of neutron. Okay, the next one, Yukawa belongs to Japan, and given the concept of nuclear forces, theory of nuclear forces. Okay, Hideki Yukawa, complete name, belongs to Japan. Okay, 28th scientist, 29th scientist to mention Homi Jahangir Baba, very famous from India, our country, and he has given the concept of cascade process of cosmic radiation. Okay, the next person is Landua. Okay, Landua. Landua is from Russia, and he has given the concept of theory of condensed matter, one concept. Another concept, liquid helium. Theory of condensed matter, liquid helium. Two concepts he has given, Landua. And the 31st scientist to mention is Chandrasekhar. Very famous, no, Chandrasekhar limit he has given. Very famous concept, this Chandrasekhar limit. I will explain what is that. And also he talks about the structure and evolution of stars. Okay, see, according to Chandrasekhar, when it comes to Chandrasekhar limit, what he tells is, when it comes to Chandrasekhar limit, what he tells is, I'll write here, any star which is having a mass of 1.44 times the sun will not form white dwarf. Just 1 minute, guys. Okay, will not form white dwarf. Rather, it will actually uh, become neutron star, it seems. Okay, neutron star. Okay, this is what is there in Chandrasekhar limit. I'll repeat it again. Any star which is having a mass of more than 1.44 times the sun will not form a white dwarf. Instead, it will become neutron star. This is what is given by Chandrasekhar limit. Very famous concept. This is Chandrasekhar limit. Okay. The 32nd scientist. The name is John Burdeen. John Burdeen has given the concept of transistor, and he has also given the concept of theory of superconductivity. Okay, transistors we know, no? Okay, they are small objects, transistors. Okay, it will be like this transistor. Okay, it will be like this. I will actually draw the diagram of transistor. Just wait. It will be like this, and it will be having three lines like this. Okay, 1, 2, and 3. Okay, this is the transistor, and this 1, 2, and 3 are emitter, base, and collector. Okay, emitter, base, and collector. 1, 2, 3 pin is there, no? This pin or this one. Okay, see, transistors, why they are used? They are used to control and regulate the flow of electronic signal. Okay, control and regulate, I'll write here, control and regulate the flow of electronic signals. For this purpose, transistors are used, controlling and regulating flow of electronic signals. See, there are types of transistors. Okay, we have bipolar function transistor. Bipolar function transistors are there. Okay, and also we have FET transistor. FET means the field effect transistor. Bipolar function transistor, field effect transistor. And within this bipolar function transistor, we have NPN transistor. We have PNP transistors. Okay, there are types within BFT transistor. Okay, so that's it about transistor, guys. Now let's actually move on to next one. Just 1 minute, where it went here. 33rd one, no? 33rd one we have to explain. Towns belongs to USA country, and he has given the concept of maser and laser. Very important. Maser and laser. Sir, what are these masers and what are these lasers? If you ask me, I will tell. See, masers are devices. Masers are device that produces a coherent. Masers are devices that produces coherent electromagnetic waves. Okay, in simple words, masers are nothing but devices that produces coherent electromagnetic waves. And then what are lasers? We know, no, lasers. Okay, we have heard, no, lasers. Okay, they will produce narrow beam of light. Okay, lasers are nothing but they will produce narrow beam of light. Okay, see, laser is also a device. Laser is also a device that will stimulate atoms or molecules to emit light at particular wavelength and amplify that light. Okay, there are atoms or molecules that will emit light at a particular wavelength and amplifies light to produce a narrow beam of radiations, what is known as laser. Okay, that is what is laser. I'll repeat it again. They are nothing but devices that will stimulate atoms or molecules to emit light at a particular wavelength and amplifies that light to produce a narrow beam of radiations called a laser. Okay, very simple definition of laser I have told. Okay, we know no laser. You may ask us, sir, what are the applications of laser? See, laser treatments are there now. In treatments, they will use laser treatment. Laser printers are there. Okay, they are some of the applications of a laser. DNA sequencing instruments also. In DNA sequencing instruments also, lasers are used. Okay, lasers are also used in barcode scanning. Barcode scanning. Okay, these are some of the applications of laser. Okay, that's it about the 33rd scientist. Now let us actually mention the last scientist. Okay, Abdus Salam. The last mentioned scientist here is 34th one is Abdus Salam. Abdus Salam belongs to Pakistan and he has actually contributed towards unification of weak and electromagnetic interactions. I'll repeat it again. Unification of weak and electromagnetic interactions given by Salam from Pakistan. Very famous scientist. Okay, that's it, guys. These were some of the very famous scientists, their country of origin, and the contribution they have given towards physics. Okay, we have actually nicely mentioned here. Okay, you memorize this one. Okay, once you understand the concept, you have to memorize. Okay, because memorization is needed now to reproduce in examination. Memorization is needed. You have to memorize. That's it, guys. Thanks for watching.